Welcome students. In this video we are going to solve some problems regarding the transformers. Few problems we are going to discuss. Let's start with the fundamental problem. So this is the problem number 1. So this is a problem number 1. Here let's read the problem. A 25 kVA lossless transformer, it's been a lossless transformer, has 500 turns on the primary and 40 turns on the secondary side. The primary is connected to 3000 volt 50 Hz mains. Determine primary and secondary current at full load, the secondary EMF, the maximum flux in the core, and no load current can be neglected. Okay. So, we can neglect the no load current. We have to find out 3 components: primary and secondary current, secondary EMF, maximum flux in the core. So, before solving this problem, let us write down the given data. So, the given is the power rating of the transformer has been given, P has been given. It is a 25 kVA transformer. The number of turns is there. Okay, number of turns in the primary 500 and number of turns in the secondary is 640. Okay, then what else has been given? Primary is connected to 3000 volts. So, V1 is equal to 3000 volt. So, let us consider a transformer like this. Okay. So, this is a transformer, 25 kVA transformer. Here primary side we have 500, secondary side we have 40. The primary is connected to the voltage source. So, that is 3000 volt, okay, 50 Hz. Okay. Now, the frequency you have to write down 50 Hz. Now, so we have to find out these parameters. So, to find. So, the first component is primary and secondary current. At full load. Primary and secondary current at full load. Okay. So, that is an important thing, full load condition. So, primary will be considered as I1, secondary will be considered as I2. So, I1, I2 we have to find out. Okay. So, since it is a lossless transformer, we have to consider that induced EMF will be equal to the supply voltage. Okay. So, as per the transformation ratio, E2 by E1 is equal to N2 by N1 is equal to K. Okay. Therefore, K is equal to, we know that N2 and N1 value. So, N2 by N1 is equal to K, which is equal to N2 is nothing but 40, okay. N1 is nothing but 500. So, you will get 4 divided by 50, that is nothing but 0.08, 40 by 5, 8, okay, 0.08. Okay. Now, if K is equal to 0.08, we know that E1 is equal to V1 is equal to 3000 volt, then E2 is equal to E1 into K, that is nothing but 3000 into 0.8, which is equal to 240 volt, which can be considered as V2, since it is a lossless transformer. So, we find out the E2 and V2 value. Now, we have to find out the I1. So we know that I1 is equal to we know that for a transformer, lossless transformer, the corresponding apparent power rating of the transformer is equal to V into I. The power rating of the transformer is equal to V into I. Therefore, I1 is equal to S by V. S is nothing but apparent power. Okay. So, S by V, V1. So, 25 kVA. So, 25 into kVA 1000. Okay. This is nothing but VA rating. Okay. kVA rating means into 1000. Okay. Divided by V1 3000. So, you will get the value. So, 3000 will be cancelled. So, 25 by 3 you will get 8.33 amps. So, this is I1 value. Similarly, I2 value is equal to S by V2. We know the V2 value. V2 value is nothing but equal to E2. So, 25 into 1000 divided by, what is the E2 value? 240. So, if you substitute E2 value, so 240. So, if you calculate this, cancel it, you will get the amps rating of 104.16 amps. So, this is the corresponding primary and secondary current. So, this is the first answer for the first question. Okay. The corresponding primary current and the secondary current for the given transformer, and we have already find out the secondary induced EMF also. So, this is for the second answer. Okay. Induced EMF for the secondary. So, 240 volt will be the secondary induced EMF. Okay. Then third one, maximum flux. So, we know that E is equal to 4.44 F phi m N1 or N. Okay. So, for E1 4.44 F phi m N1, for E2 4.44 F phi m into N2. So, you can use any one of this formula, and you can from this formula phi m is nothing but the maximum flux. Okay, that is the phi max. Okay. So, we can calculate the phi m. The phi m is equal to E1. Let us take the first equation, E1 divided by 4.44 into F into N1. So, E1 is nothing but 3000 divided by 4.44 into 50 into N1 is nothing but the number of turns in the primary side. Okay, that is nothing but you will get how many turns was there? 500. Okay. So, if you calculate this, you will get the answer. Okay, 3 divided by 25 into 4.4, you will get the answer as 0.02702 Weber. It will be nearly to this value. Okay, this can also be written as which can be written as 27.02 into 10 to the power minus 3 Weber, that is 27.02 milli Weber. Okay. So, this is the corresponding maximum flux for the given circuit. Okay. Thank you very much for watching this video. Hope this video gives some knowledge about how to solve the problems for a simple transformer circuit given. Thank you very much.